Dear students, we'll continue our discussion on the hardened concrete. So next we will take maturity concept to our discussion. So in the previous session I had explained about how the time or the period it influencing or influences the strength of the concrete. However, it is not only the time. Besides time, temperature is also very important factor, especially when it is in the early stages of curing. So this will also influence the strength. So hence the maturity is a parameter. So it is made by considering both the effect of time as well as temperature into account. So here we can see the maturity is given by the summation of time into temperature. So that is nothing but it is a function of summation of a product of time and temperature. So this is what it is called as maturity of the concrete. So from the several studies which has been made on the concrete in the field of concrete technology, so researchers have concluded that so the concrete continues its hydration up to the temperature of minus 11 degrees centigrade. So minus 11 degrees centigrade is taken as a benchmark to calculate this maturity in our calculation. So usually maturity is measured in terms of degree centigrade hours or degree centigrade days. So let us discuss about an illustration here at this point. So by the help of which we can able to understand about the maturity of concrete. Let us say a sample of concrete cured at 18 degrees centigrade for 28 days for its complete maturity. So its maturity would be equal to, so 28 days, it has taken 28 days into 24 hours. So that will give you time into the temperature effect has to be considered by taking minus 11 degrees centigrade as a benchmark, as I said. So 18 degrees centigrade, it has undergone the curing at 18 degrees centigrade. So 18 minus of minus 11 we have to take. So this is, we need to treat this minus 11 as constant. And whatever may be the temperature, maybe it is 20 degrees centigrade also, 20 minus of minus 11 only we have to take. So the answer will be 19,488 degrees centigrade hours. So this is the maturity of fully cured concrete. So for all the applications, for all the calculations, so we will be taking so 19,800 degrees centigrade hour as a standard value of maturity. The next one is nothing but the types of concrete strength. The concrete has got different strengths. So it is nothing but compressive strength is there, tensile strength is there, it is possessing shear strength, bond strength, impact strength, fatigue strength, etc. So out of which, for our structural safety, we need to ensure the compressive strength, split tensile strength we can take, as well as flexural strength we can take as a benchmark in assessing the strength. However, this bond strength is nothing but it is the strength which is possessed by the reinforcement which are embedded in the concrete. So through the adhesion and the bonding, so that is nothing but which is created by the friction which is induced between the interface of the reinforcement and the concrete. So that is considered as bond strength. Impact strength is nothing but it is the strength of the concrete which is observed under suddenly applied load. Fatigue is nothing but it is repeatedly applied load. So fatigue strength is nothing but the nature of the or the strength of the concrete possessed under or given or observed under the repeatedly applied load. That means loading cycles will be there. So here in our context, so we will be concentrating on the compressive strength, split tensile strength, as well as flexural strength. Okay. Now moving forward, compressive strength. So this compressive strength is nothing but you know the this compressive strength which can be tested by casting the cube concrete cubes which are of size 15 by 15 by 15, 15 centimeter width, 15 centimeter depth, 15 centimeter the length or the something but b into d into l. So this cube we are going to cast in the laboratory and which is cured for 28 days by keeping inside the water tank. So then after 28 days completion of curing period, so the cube will be taken out and it will be subjected under compressive load. So that means it is tested under CTM, compression testing machine. So then we will observe what is the maximum load which can be taken up by this cube before it undergoes rupture or failure. So this load which is divided by the area over which the load has been applied. So that is nothing but the surface. So 15 by 15 centimeter. So that is nothing but what? The area over which the load has been acted. So 15 by 15 centimeter square. So that we need to consider in the denominator. So ultimately we can able to find what is the compressive strength of the tube in terms of Newton per mm square or MPa. So these are the precise units of expressing the compressive strength. Okay. So suppose you are designing M20 grade concrete, as I said before, so it should possess 20 Newton, minimum 20 Newton per mm square after curing period of 28 days, after the completion of 28 days curing period. So this is regarding the compressive strength. So however, the different codes uh, gives different types of testing. So there may be cylindrical specimen which can be casted in the laboratory and may be subjected under compressive load. So thereby we can also calculate what is the compressive strength. However, in the Indian standard code, so this cube specimen is prescribed. So that is nothing but compressive strength test should be conducted on the cube specimen. Okay. So if you are taking that is a cylindrical specimen and cube specimen and its influence or that means the shape of these specimen how they are going to influence the strength of the concrete, so that can be uh, illustrated with the help of this particular chart where you can find the relative strength which is on the y-axis and height to diameter ratio which is on the x-axis. So now our condition for this uh, cylindrical specimen, maybe it is nothing but what? The height will be more. So height will be more. So it is nothing but h by d ratio we are talking about here. H by d ratio. So height, if it is more, means nothing but what? So it will become slender. It will become slender as well as the ratio also will become more. So that is nothing but 2.53, 3.54 resembles the height of the sample, that is cylindrical sample is more compared to its diameter. So as the slender the member or the slenderness increases, the strength decreases. Strength decreases. There is a reduction in the strength, which is observed in this particular chart. Similarly, there is a relationship which exists between cylindrical compressive strength and the compressive strength of cubes. Okay, so which is given by this particular relationship. Fc cylinder is equal to 0.85 minus zero point 0.8 into Fc cube. So Fc cube is nothing but compressive strength of cube specimen. So Fc cylinder is nothing but compressive strength of cylindrical specimen. Okay. So if the failure pattern are considered, so there are three failure modes for cylindrical sample. Under axial compression, concrete fails in shear. The separation of the specimen into columnar pieces by what is known as splitting or columnar fracture. So this type of failure is called as splitting or columnar fracture. So that you are observing here in this particular figure, or combination of shear and splitting failure. So any cylindrical sample which is made up of concrete fails by either shear or a columnar fracture, or by the combination of both shear and splitting failure, or shear columnar fracture. Okay, so these are illustrated here in this particular uh, diagrams. So there you can see A, B, C. A is nothing but shear, failure by shear. B is nothing but failure by splitting or columnar fracture, and third one is nothing but combination of both. So the same testing procedure which has been highlighted here in this particular slide. So about the dimension of the cubes or dimension of the cylindrical specimen that you can note down from this particular slide. So testing of cylindrical sample with 15 centimeter dia and 30 centimeter height. So that means height to diameter ratio is nothing but what? So height to diameter ratio, height is 30 centimeter and diameter is 15. Height to diameter ratio becomes 2. So h by d ratio is equal to 2. So such a sample is prepared, such a cylindrical sample is prepared, whereas the cube specimens of 15 centimeter by 15 centimeter by 15 centimeters are casted and will be cured. Both samples may be cured in the water, inside the water, for about 28 days before testing. So this is what the photo plates describing the testing of cube specimen as well as a cylindrical specimen under the CTM. So next comes the tensile strength of concrete. So as I said before, it is one of the strength of the concrete. That's nothing but tensile strength. So that also can be tested, but it is not. There is no way of directly applying the tensile load on the concrete. So hence there is no practical method by the help of which the tensile load which can be applied on the concrete, so that precisely that tensile strength which can be measured from that particular technique. So therefore, indirectly we are applying. So that is the limit. Indirectly we are calculating by directly applying the compressive load on the specimen. So this particular testing, which is prescribed in order to determine the tensile strength of concrete. If you are interested to calculate the tensile strength of the concrete, so we need to cast a cylindrical sample of h by d ratio is equal to 2, again same dimension. So then we need to keep the specimen as it is shown in the figure under the CTM, and properly the capping should be done. So that means the tip of these cylindrical sample should be protected so that the immediate crushing should not happen. So then what we have to do? So we need to place a plank of plywood or a strip of plywood as it is shown in the diagram, and the compressive load which will be applied. So here by doing so, so we are applying the compressive load on the surface. So that means on the extreme fiber of the concrete, the nature of the load is nothing but compressive load. Although the compressive load is applied, so inside the body of the concrete, there will be tensile load. There it is indicated with the arrow mark. So there you can find the tensile load which has been developed inside the body of the concrete. So that can be calculated with the help of simple formula like FCTC is equal to 2P divided by 5LD, where P is nothing but the load and L is nothing but length of the specimen and D is nothing but a diameter of the sample. So these are the photo plates again showing the testing of concrete under this split tensile testing method or procedure. Next comes flexural strength. So it is not tensile strength, it is flexural strength. Okay. So here you can correct this. So this is nothing but flexural strength test on concrete. So the flexural strength or modulus of rupture FB is given by this particular formula. You need to know that particular formula, then we will come to know or we'll be having an idea how we can get these many parameters. So FB is given by PL by BD square. So P means nothing but the load, L means nothing but the span, that is nothing but this is the support, this is one of the support again. So what is the clear distance between this support? So that is taken as span length L. B is nothing but the dimensions. B is nothing but the width of the specimen. D is nothing but depth of the section. Okay. So now suppose if you are applying by means of this roller support, okay, by means of this roller support on the surface. So this is the beam we are making. So for the flexural test, we need to cast a beam of concrete beam, over which the roller which can be applied suitably in order to apply the load. In order to apply the load, assume that there are two rollers over the surface of the beam. So now I have applied the compressive load. So what will happen here after applying the compressive load? After some moment, so you can see some crack, the formation of the crack on the body of this or surface of this beam. So this crack which is formed at a distance greater than 20 centimeter for 15 centimeter specimen. So that means the width of the specimen, sorry, depth of the specimen, or this crack distance which is greater than 13 centimeter for 10 centimeter specimen. That is nothing but 10 centimeter or 15 centimeter is nothing but the depth of the section. Depth of the section. Okay, depth of the section we are going to have depending upon the mold dimension. So either it will be of 15 centimeter or 10 centimeter. Now suppose the A, that is nothing but the crack distance from the nearest support is greater than 20 centimeter, or crack distance from the nearest support is greater than 13 centimeter for 10 centimeter specimen, then we need to use this particular formula. This That is nothing but FB is equal to PL divided by BD square. Now there is one more formula. So by the help of which again we can calculate so the flexural strength of the concrete. So that is nothing but FB is equal to 3PA divided by BD square. 3PA divided by BD square. So this is the typical or special condition when the crack which has been appeared here, okay, so which is existing at a distance lesser than 20 centimeter but greater than 17 centimeter for 15 centimeter depth of the specimen. So this is nothing but 20 centimeter or 17 centimeter. It is nothing but measured with respect to nearest support. Nearest support. Similarly, if you are using 10 centimeter depth of this specimen, so then the crack distance is nothing but lesser than 13.3 centimeter but greater than 11 centimeter from the nearest support. So then we are going to use this particular formula. Okay. So in this particular formula, so either PL by BD square or 3PA divided by BD square. A is nothing but, as I said, the distance between the line of fracture and the nearest support. Okay, measured on the center line of the tensile side of the beam. Okay, with the help of the scale. B is nothing but the width of the specimen. B is nothing but the depth of the section. L is nothing but supported line. P is nothing but maximum load. Okay, so by the help of which we can able to calculate what is the flexural strength of that particular concrete. That particular concrete. Okay, so moving forward, so there are several relationships between these strengths. So that means compressive strength and tensile strength of the concrete. So as you can see here, direct tensile strength FCT is equal to 0.35 square root of FC. FC is nothing but compressive strength. Similarly, split tensile strength is equal to FCTS is equal to zero point 0.5 root of FC. FC is again the compressive strength of the concrete. And last one, flexural tensile strength is equal to FCT is equal to 0.64 square root of FC. So that is nothing but again the compressive strength of concrete. So there is a this is nothing but simply a thumb rule by the help of which if compressive strength is known, so then we can calculate roughly what is the direct tensile strength or split tensile strength or even flexural strength, the tensile strength. Okay, so that's it for today. So hope you are fine. Thank you. We will discuss further uh, topics, whatever it is remaining in this particular module, in the next sessions. Okay, thank you.